Good morning, students. In previous lectures, we learned how to derive electric field due to distributed charge. In today's lesson, we are going to deal numericals based on the electric field due to distributed charge. So let's start today's lesson. Suppose we have an infinite wire of charge density lambda coulomb per meter. Let at a distance a charge small q and mass m is placed. Let this distance be small d. Let this charge be placed at equilibrium. Now, if we displace slightly this charge, then it will start to oscillate. We have to find the time period of oscillation of this charge. Now pause the video and let us try to find the time period of oscillation. Since it is in equilibrium, now there will be two forces acting on this charge. One force is upward, which is electrostatic force, and the other force is downward, which is due to its weight. As the charge in equilibrium, it is in equilibrium, the force, electrostatic force, must be equal to mg. Now this electrostatic force, there must be an electric field at point charge q. There must be an electric field due to this infinite wire, and that electric field can be denoted as E. So the force will act at the point charges QE equals mg, and electric field due to infinite wire is 2k lambda by d, which we have already discussed in previous lesson. So here we can write q 2k lambda by d equals mg. Now when this charge is slightly displaced, the new equation, what will it become? Let us find the new equation. Let the charge is slightly displaced upward. Now when the charge will be displaced upward, let through x, here the net force will be F net equals, what will be the net force? mg minus Fe. Suppose this force, electrostatic force, will act upward, it will be taken as positive, and the weight is downward, so it will be taken as negative. So here we can write Fe minus mg. In place of Fe we can write 2q k lambda by d. Now here the distance will become d plus x. So here d plus x minus mg. As x is slightly displaced, we can write 2q lambda by 2q lambda k by small d 1 plus x by d minus mg 2q k lambda by d 1 plus x by d whole to the power minus 1. Now this term can be expanded binomially and we get a term 2qk lambda by d 1 minus x by d. Higher power terms can be neglected as x by d much less than 1. So higher power terms can be neglected minus mg. Okay, in place of 2qk lambda by d, 2qk lambda by d, we can write mg. So here we get mg 1 minus x by d minus mg equal to mg minus mg x by d minus mg. So we get net force equals minus mg by d into x. So here the net force F is directly proportional to x and it is in the opposite direction. So this particle is in SHM. One question can be arised that so that the particle is in SHM. So by this expression we can prove that this particle is in SHM. Now let us find the time period. We can compare this equation by minus kx, where k equals can be written as mg by d. As the particle is in SHM, we can write this formula, k equals mg by d. Now time period of oscillation. Time period of oscillation is t equals 2 pi root under m by k. T equals 2 pi root under m by, in place of k we can write mg by d, cancel. So t equals to 2 pi root under d by g. So this gives the expression for time period of oscillation of the particle. So there are two types of question in this question. One, we have to prove that particle is in SHM or not. Another type, we have to derive the expression for time period of oscillation of the particle if it is in SHM. Okay, let's move to another question. Now this question is based on electric field due to infinite charged wire. Let us take a question on circular charged wire. We have a circular charged wire, positively charged. Let a circular charged wire like this. Let a circular charged wire, and on its axis let a charge q is placed. Now for the particle in SHM, let this charge is negative, minus q. Let the ring has radius r and the distance of charge q from the center of the ring is x. Same question. if the charge q is displaced slightly, then find the time period of oscillation of this charge q. Pause your video. Let us try to find the solution. Let us find. Suppose the electric field due to this ring at this point is towards right, but the force acting on this charge minus q is towards left. If we displace this charge through small displacement x, then it will oscillate about this mean position. Obviously, this particle will be in SHM. Let us write the expression F equals minus QE, we can write, or F equals minus Q. Electric field due to this circular charged ring. What we can write? Electric field due to this circular charged ring can be written as K. Let this ring has charge capital Q. K Q x by r square plus x square whole to the power 3 by 2. As x is slightly displaced, we can remove x, so we get the expression minus k q q by, if we remove x, we get the expression r square whole to the power 3 by 2 into x. So square will be cancelled out, minus k q q by r cube into x. So this gives the expression of force. As it is opposite to x, so it is in SHM, F directly proportional to x, and it is opposite to x, so it is in SHM. We can compare it with minus kx. So here k, this k and this k will be different. This k is like spring constant or force constant, and this is Coulomb's constant. So expression for k is k q q by r cube. Time period t equals 2 pi root under m by k. By putting the value of small k, we can find t equals 2 pi root under m by k q q by r cube, and we get the expression of time period 2 pi root under m r cube by k q q. So this gives the expression for time period of oscillation of a point charge q when placed in front of a charged circular ring. So these type of numericals you can practice at home. These are some of the examples. Okay, there are some questions based on constant electric field. Based on constant electric field. How this behaves? Actually, we will discuss later that there is a topic electric field lines, and we have to discuss about the properties of electric field lines. We will discuss it later, but there are some questions in NCERT and in different books also. You can practice constant electric field. How it behaves, constant electric field, how it behaves. If you simply relate this quantity to any other quantity, we can relate it with gravitational field, like Earth. Now there is a constant gravitational field directed downward towards the Earth. We can replace it by constant electric field. How? We can take a substance called capacitor. You will know this topic. Actually, Uma ma'am has discussed this topic. Capacitor. So basically the design of capacitor is somewhat like this. There are two plates, one is positively charged and the other is negatively charged. Now between these two plates we get a constant electric field. So we easily can produce a region of constant electric field. Now in constant electric field there are questions based on this topic. Suppose if it is asked that from a tower a stone is thrown horizontally. A stone is thrown horizontally. What is the path of this stone? Path of this stone. Or from tower a stone is thrown or a stone is dropped. A stone is dropped, simply dropped. In first case and in second case. In first case, a stone is thrown at different angles also. Let the stone is thrown at different angles, horizontally or at different angles. And in second case, a stone is dropped. What will be the path of the stone in second case? Simply a straight line. Straight line. And what will be the path in first case? You will answer as parabola. The path is parabola. So, whenever, and which field is acting here? Field is gravitational field. And which is constant. Gravitational field is constant always. So, whenever a particle is either dropped or thrown horizontally or at different angles, the path will be either straight line or parabola. The path will be either straight line or parabola. Same question can be asked in constant electric field. Let a region of constant electric field. How we will get the constant electric field? We discussed it already. Now, if a charge capital Q charge is thrown like this, what will be the path of this charge? As this region is a constant electric field, and Q charge is thrown horizontally or perpendicular to the field, we will get the path of parabola. There are always two paths, either parabola or straight line. As this charge particle is thrown perpendicular to the electric field and not parallel to the electric field, so the path is parabola. And if there is electric field, constant electric field somewhat like this, and a charge Q is thrown parallel to the field, suppose it is thrown parallel to the field, what will be its path? Its path is straight line. So, to practice these type of numericals, we have to command projectile, as we have already studied in class 11, chapter 3, motion in a plane, projectile motion. Question can be asked somewhat like this. We can take plate, two plates of either charge, positive and negative. Let the plate length be d. A charge small q is thrown. Let the separation be. Let the length be L and separation be d. Let at a distance d by 2 a charge is thrown with velocity u. Now we have to find if the charge, first we have to show the path, how it will travel. Let the charge is positive. Now pause your video and first state whether it will go to path 1, or to path 2. As it is positive charge, the negative plate will attract, and so path 2 is the correct answer. Now second question is asked, if the charge strikes at the edge, find time to strike at the end. It's simply like projectile. Now what is the expression in projectile motion? What we have read is tower, a stone is thrown with velocity u and it goes somewhat like this. Let the height of tower be h. Now we use the expression h equals half gt square, where g is the acceleration. So t equals 2h by g under root. Here in this case we will neglect the effect of gravity. In question it is given also, neglect the effect of gravity. So here in place of g, which is the acceleration due to gravity, we will replace it with the acceleration due to electric field. So here let the electric field between the plates be E. Force acting on this charge Q will be F equals to QE, and we can equate it with MA. So A equals to QE by M, where M is the mass of charge. So here we get the acceleration. So time taken T equals, we can write T equals under root 2h. In place of h we will write this height d by 2 divided by acceleration QE by M. So T equals under root MD by QE. So this gives the time in striking this charge at this point. So these type of numericals on constant electric field can be we can easily understand it by solving the numericals based on projectile. So let's solve rest of the numericals from NCERT book. Practice the numericals. Till then, stay safe, stay at home.